Okay, so a polyhedron is a three-dimensional solid with many polygonal faces. For example, like this tissue box, all the faces are polygons. Polygons are shapes with straight sides and they're closed. So this is a polyhedron. A cylinder is actually not a polyhedron because a circle isn't a polygon. So when we talk about polyhedrons, we're talking about things with straight edges and flat sides. Poly means many. It's a Greek word. Hedron means surfaces. Again, a Greek word, and that's how that word is made up. And getting into prisms. I know you've heard the word prism before. By definition, a prism is a polyhedron with identical two bases that are congruent. So here you see a pentagon on the bottom and then a pentagon on top. These two bases are completely congruent. So if you had the area for one of them, you also know the area and dimensions for the other one. And then connecting those two bases are rectangles. The way we identify a prism is based on the shape of the base. So here we have a pentagon, so it would be a pentagonal prism. This one is a triangular prism. A lot of times triangular prisms especially are kind of like drawn sideways. This is still the base, even though it's like the front of the shape. This is the base the triangle is, and then it has rectangles all around it. We're going to fill this in here. So this would be a triangular prism. This one looks like a cube. We're going to call it a rectangular prism. Or we'll say or a cube. It does look like a cube. A cube would have the same, like a square all the way around with the same dimensions. This one has a hexagon base, so this would be a hexagonal prism. And then this one with the pentagon, pentagonal prism. At some point throughout the year, we will find out or learn how to find the area of a pentagon. Some of you that are really good at math or just like see math easily might be able to figure out how you'd find the area of a pentagon. If you were to break it up into triangles, you could find the area. Just life hack. Okay. Pyramids. Pyramids are like the Egyptian pyramids. A pyramid is made up of a base and the lateral sides are triangles. Here we have the base. The top point is called a vertex. We identify pyramids by the shape of their base. So here the base is a hexagon, so this would be a hexagonal pyramid. This has a rectangular base, so a rectangular pyramid. Then here, pentagon, pentagonal pyramid. And then the triangle base here would be triangular pyramid. Another popular pyramid is a square pyramid. That would mean the base is a square. Okay, next page. Flipping, you got it? Okay. Now working on the top here. I move this over, I can zoom in a little bit. Okay, so other solids, notice they don't call them polyhedrons because they aren't. A cylinder, as you can see, a cylinder has two bases. The bases are circles. Bases are two parallel and congruent circles. The side around the cylinder, if you were to draw this thing flat, you have a circle, and then a rectangle. To find the length of that rectangle, just kind of building concepts, to find the length of this, you would actually need to find the circumference of the circle. So if you're finding surface area and finding the area of each of these shapes, you would need to find the circumference of the circle to find this length. Then we have a cone. Cone has a vertex and a base. Cross this out. That goes with cylinder. And then a sphere, a set of points that are the same distance from a given point, called the center. So that's the definition of sphere. I've seen that on standardized testing before. Definition of a sphere is all the points equidistant from the center. Was it? Okay, now we're moving down here. Surface area and volume of prisms. This worked, what we did in my fourth period that worked really well is we went through and did all the surface area first for all the shapes and then went back and did all the volume. Surface area seems to take a little bit more work. So we're gonna start there and then we'll just breeze through the volume after we're done with all the surface areas. So we're gonna find surface area of these three shapes. The surface area, you're finding the area of all the surfaces. So you'd find the area of each one of these sides, add it together to find surface area. That's maybe what you did in middle school. I'm going to be teaching you how to use the equation. There is a reference sheet that you'll get for FSA, and they just released the new one that goes with the new test. And what's nice is the new reference sheet actually has way more equations than they used to have. So surface area of a prism. Obviously, you'd have to be able to identify it as a prism, so that's step one. But surface area of a prism is this equation here. So we're going to write that down on our paper. And so we'll write it down. SA equals 2B plus capital P times H. And I feel like just saying that, the equations are there is almost like a trick, because unless you were really familiar with this, you would have no idea what that means. So what this means is capital B is area of the base, P stands for perimeter, and I'll show you how to use that, and then height of the prism. So filling in dimensions for our, it looks like a cube here. So we're gonna have 4 by 4 by 4. Okay, so first surface area, we need 2 area of the bases. Now our base here is a square. And this pencil's not working. Okay. The base here is a square, so the area of the base would just be 4 by 4. And you have 2 of those, the top and the bottom. So that's what that stands for. Then perimeter, it's talking about like perimeter of the cube or perimeter of the base, same thing. This would be 4 all the way around, so perimeter would be 4 plus 4 plus 4 plus 4, which would be 16. And then the height of our prism is 4. Then once you have all this plugged in, follow order of operations. (32 plus 64 equals 96 units squared. So the surface area of the shape is 96 units squared. That's if you found the area of each side, added it all up. Now, you could, if you aren't comfortable with the equation, you could add up all the sides if you needed to. Next, actually, make sure I'm using the same dimensions I used before. Yes, Samantha?
I have to throw something.
What's that?
She's throwing something.
Next time, just wait till after the lesson. Okay. There's the dimensions to the rectangular prism. So using the same equation, 2 times the base this time is 4 times 6. The perimeter of the base, like if this was drawn out all the way, you do 6 plus 4 plus 6 plus 4, so 20. And then the height is 3. 24 times 2 is 48, plus 60. Surface area is 108 units squared. Okay, next one is a triangular prism.
4 times 6 is 24.
Yeah. Times 2. I combined
Oh.
steps, sorry, yeah. Okay, so now we're dealing with a triangular prism. The base here is this triangle, so we need to find the area of that triangle. Plugging in the dimensions, we have 5, 4, it's right triangle, and we'll call this 3. Okay, so surface area equals two of the bases. Now we're dealing with a triangle, so it's going to be 1/2 base times height of the triangle plus perimeter times the height, which will be 3. We need to plug in the dimensions of the triangle, so it'll be 2 times 1/2, 4 times 5, plus perimeter. Uh-oh. Well, I was trying to figure it out. What do we do?
No, you were saying 2 times 1/2, and I was like 1. But then,
Oh, yeah.
yeah.
The 1/2 is part of the equation for area of a triangle. How are we going to find perimeter? Yes.
You have to use Pythagorean theorem.
Good job. Yes. Yeah, we need this side length, and they didn't give it to us, so we have to use Pythagorean theorem to find that side length. So 5 squared plus 4 squared equals c squared. 25 plus 16 comes out to 41, I believe. Yeah, square root of 41. So this is square root of 41, which equals, if I plugged it in a calculator, it comes out to 6.4 something. Yeah, we'll round it to 6.4. Okay, so now that we have the 6.4, we can add up those three numbers to get perimeter. So 5 plus 4 plus 6.4 equals 15.4 times the height, which is 3. Now we solve using order of operations. With the multiplication, you can multiply in any order. Half of 4 would be 2. 2 times 5 is 10. 10 times 2 is 20. Plus 15.4 times 3 comes out to 46.2. And then 66.2 units squared is our answer. Okay, moving on. You got it? Thank you. Next. Okay, now we have a cylinder here. Volume of a cylinder. Oh wait, not volume. We're doing surface area. Stick with surface area. Surface area of a cylinder is SA equals, Siri's trying to understand. SA equals 2B plus perimeter times the height. Same exact equation. Our base, what's our base this time?
Circle.
The circle, so we're going to have to plug in pi r squared. And then perimeter, this time isn't perimeter, it's called what? Circumference, so we're going to have to do pi times diameter for perimeter. Dimensions of the cylinder, we're going to use 3 for the radius, and height is 10 because it's easy to calculate. Okay, so then plugging in numbers, SA equals 2 times the base, which is pi r squared. Perimeter is pi times diameter. I'm going to leave it as pi times diameter times height right now.
Do you want us to use pi?
We're going to solve in terms of pi, and then we'll solve it for a number. So leave it as pi for right now. Diameter would be 6, just double the radius, and then height is 10. Okay, then solve using order of operations. So exponents, we get 9 pi times 2, 60 pi. I get 18 pi plus 60 pi, which is 78 pi. This is actually our answer in terms of pi. I know in Khan Academy it asked you to give the answer in terms of pi. You'll see that on standardized testing as well. This is actually an exact answer because pi ultimately gets rounded when you calculate with it. And you can also like type this in a box easier than you can with a rounded answer. So a lot of times you'll see them ask you to answer in terms of pi. Now if all the answer choices are just a decimal without the pi symbol, all you do is take 78, multiply it by pi, and you get 245.
0.
Yeah, I'll do 2 decimal places just because 0.04 units squared. So both of these are correct answers. It just depends on how it wants the final answer. Okay, next. Surface area of a pyramid. The equation for this is surface area equals area of the base plus 1/2 perimeter times L, which is the slant height. Well, it's the height of this triangle here.
Wait, is it one after
Yeah, so here.
It's L.
It is
Oh, the length.
yeah, of the triangle, like the side.
Hypotenuse kind of? Not really.
It's the height of just like the side triangle.
Some height when you're finding the area.
Yeah. On the reference sheet, it has, I guess you could use this. HS, sometimes they call it L. It's like the height of that triangle. So surface area. Area of the base, this is a square now. Dimensions, we'll put 5, 5, and then this we'll call 7. So area of the base, which is a square, would just be 5 times 5. And then 1/2 the perimeter, which would be 5 plus 5 plus 5 plus 5, which is 20. And the height of the triangle is 7. So for surface area, you would have to find the area of the base and then the area of each of those triangles and then add those areas up. But by doing the perimeter, you're essentially finding the area of all those triangles at one time. That's why they keep having you do perimeter. So for here, we get 25 plus half of 20 is 10. 10 times 7 is 70. So 95 units squared for surface area. Okay, next, surface area of a cone. Are you guys still with me? Still alive, still breathing? You still have a pulse? Okay. Surface area of a cone is area of the base plus pi RL. L being the slant height. Dimensions of our cone, we'll put 3. The slant height, we'll say, is 6. And from there, we can figure it all out. So surface area.
It's like looking. It just frozen and then it like.
Oh, it came back? Okay, good, it came back. Okay, so our base now, area of the base is pi r squared because we're dealing with a circle. So pi r is 3 squared plus pi r, which is 3, and the slant height is 6. Solving this, I get 9 pi and 18 pi, 27 pi. So if it asks for the answer in terms of pi, we get this. If it asks for an exact answer or all the answers are in decimals, 27 pi equals 84.82 units squared. Something else I want to point out that gets asked on the homework, and I've also seen it a lot on standardized testing as well, is they'll ask for lateral surface area. What that means is they want just like this part. I don't want to mess up my cone too much. But they want just like the part around it and not including the base. If they want just lateral surface area, if you look at this equation, you have the base and then you have everything else. So if they ask for lateral surface area, just use this part of the equation to find lateral surface area. That's all you have to do. Okay, now a sphere actually has the easiest of the equations. Surface area equals 4 pi r squared. And I'm pulling these equations exactly as they are on the reference sheet, and then we're manipulating them if needed. Surface area of a sphere Dimension we're going to use is 4 for the radius. And then solve. Or 64 times pi is 201.06 units squared. Okay. That is surface area. Now we're going to go back and breathe through the volume. Breeze through the volume. I can't. 7th period. Okay. You got it? For everybody? Okay. Now we're going back up to prisms. And now we're going to talk about volume. Before I get into the equation for volume, which we'll get to, I just want to kind of go over the concept for volume, which I'm sure most of you understand. When you find volume of a shape, you're finding the area of the base, multiplying by the height, and then you get how much volume is in this. When we talk about volume, we're technically talking about little cubes. We're finding out how many little cubes are in this box. If that's hard to visualize, you know how like at some like community events or church events or cookouts, they have like a container full of candy and you try to figure out how much candy is in the container? You could use the equation for volume to kind of hack this. Technically, if you counted all the candies on the bottom, then you figured out how many layers of candy there were in the container, you could you could multiply those two numbers. You could multiply how many are on the bottom, multiply by the number of layers, and it would tell you how many candies are in here. We do the same thing with volume, except instead of trying to count all the candies, we just count all the candies one way and the other way, multiply that to figure out how much is on the bottom, and then multiply by the number of layers, and that's volume. So whether you have a rectangular prism and you're finding the area, which is length times width, or you have a cylinder and you're finding the area, which is pi r squared, you're going to find the area of the base, multiply by the height, and that tells you how much candy is in the container. So even without the equation, or if you didn't have a reference sheet, just using the concept, you can find volume. So starting here, the equation for volume is area of the base times the height, and this is the equation that's on the reference sheet. But area of the base will change based on what kind of prism you're finding. This is a cube, so area of the base is 4 times 4, the area of a square, times the height, 4 again, 16 times 4 comes out to 64. So the volume here is 64 units cubed, because now we're dealing with volume. Here, same idea. Now we're finding the area of the rectangle, multiplying by the height. So volume equals 4 times 6, multiplying by the height. 24 times 3 comes out to 72. Now for this, I need to find the area of a triangle and then multiply by the height. So I'm still using the same equation, area of the base times the height, but now my base is a triangle, so I need to use the equation for area of a triangle. And then base and height of the triangle, 4 and 5, times the height, which is 3. And then you can multiply these in any order. Half of 4 is 2, 2 times 5 is 10, 10 times 3 is 30, so volume equals 30 units cubed. No pi here because there's no circles. Next. Okay, equation for volume of a cylinder is volume equals area of the base times the height, the exact same equation. Finding the area of the base, multiplying by the height. Only difference is our base is now a circle, so we're using pi r squared and then multiplying by the height. Radius is 3, height is 10. 9 times 10 would be 90, so volume equals 90 pi units cubed. This would be in terms of pi. To find the exact number, multiply it by pi, and you get 282.74 units cubed. Next, volume of a pyramid. Here's where the equation changes. If I were to find the area of the base and multiply it by the height, it would take up all this space that really isn't part of the pyramid. So a pyramid or a cone is actually 1/3 of that space. So 1/3 area of the base times the height. So this equation here, 1/3, the base here is a square, so 5 times 5, and the height is, actually we don't have a height in there. Here's our height. The height would be the perpendicular distance from the center to the top vertex, and we'll call that 6. Now, 25 times 6 times 1/3. In a calculator, you could do 1 divided by 3 times 25 times 6. That would work. Another thing, you could do 1/3 of 6 is 2, and then 2 times 25. What I'm going to do is just 25 times 6 is 150. 1/3 of that, you could divide that by 3 to get 50. So volume equals 50 units cubed. Thank you. Next, you have a cone. Volume of a cone. Volume equals 1/3 area of the base times the height. The base is a circle. The height here would be the perpendicular height from the center to that vertex, and we'll call it 5. So volume equals 1/3. Area of the base is pi r squared. Height is 5. You get 9 pi. You can multiply these in any order. 1/3 of 9, I can do that in my head, and I'll get 3 pi times 5. So I get 15 pi units cubed for the volume. And if I were to multiply that by pi, it would come out to 47.12 units cubed. And then we have volume of a sphere. Volume equals 4/3 pi r cubed. That's volume of a sphere. So volume equals 4/3 pi r is 4 cubed. 4 times 4 times 4, that came up a lot today. It is 64. In a calculator with the 4/3, the best way to go about it is 4 divided by 3, and then times 64. I get this decimal, 85 and 1/3. If I left it in terms of pi, it would be 85 and 1/3 pi. I guess you could do that, but I'm just going to multiply it by pi. And I get 268.08. Okay. And the last step, we didn't fill in any of the blanks, so let's go through and fill in the blanks for each one of these. Okay, so to find the surface area of a prism, you find the area of each face and add it together. We'll use the equation, which does that. To find the volume of a prism, you find the area of the base and multiply by the height. Over here, to find the surface area of a cylinder, you find the area of each face. To find the volume, find the area of the base and multiply by the height. Now we have a pyramid. To find the surface area, you find the area of each face and add it together. find the volume, find the area of the base, multiply by the height of the pyramid, and divide by 3. Or multiply by 1/3, however you want to put it. And then down at the bottom here, to find the surface area of a cone, you find the area of each base and add them together. To find the volume of a cone, you find the area of the base and multiply by the height and of the cone and divide by 3. Okay, one more thing that is in there that I didn't mention. So let's say you have a cylinder right here. For most of these examples, we were just given radius. Sometimes in the homework, it'll show an entire line drawn across, and it'll say like 14. If that entire line is drawn across, 14 is the diameter, and sometimes you have to divide that by 2 to get just the radius. So just keep that in mind. If the line's drawn all the way across, that means that the number they gave you is the diameter. Just divide